Here's another matching question that's quite a good one, where I have to match up which of these ellipses match up with which of these four equations. To begin with, probably I would look to see which ones are moving off the origin and which ones are on the origin. So this one's on the origin, this one's on the origin, this one's off kilter a bit, and this one's off kilter a bit. Okay, so these two ones that are on would have equations that look like one of these ones here, where there's just an x squared or y squared, there's no x term or no y term. So these two over here would be 19 and 20, and these two over here are going to be 21 and 22. Don't know which, but we can find out. Let's take number 19 and rewrite it in the right form. So I have 16x squared plus 4y squared is equal to 64. I know the equation over here has to have a 1, so I'll divide each term by 64. So divide 64, divide by 64, divide by 64. Okay, so I get equals 1, and then here I'll get x squared over 4 plus, here I'll get y squared over 16. So here, since the larger number is under the y squared, then it must mean that the ellipse looks like that. Okay, so it's not a sideways one, it's a leaning or one on end. So I know that the ones that are centered on the origin are these two, and this one has to be up on end. Looks like this is the one there. So I'd probably pick C for that one, and without even looking I'd pick D for that, or A for that one. Without even, I could divide everything by 20 and then just see which one has a bigger number. This one probably would, so it's an ellipse that's sort of lying down instead of on end. Okay, so let's take a little bit more closer look at 21 and 22. Let's go to a different color. So 21, I'll do it over here. So 21 has x squared plus 9. Oh, let's get them in the right order. So it'd be x squared minus 6x plus 9y squared plus 90y equals minus 225. Now, with these ones that are off the origin, what you need to do is complete the square for each one of these. So this one here, I don't have a coefficient, so I'm just going to divide by 2 and square it. So it'll be x squared minus 6x plus 9. This one has a 9 in front, so let's factor that 9 out of that one first. So it'll be y squared plus 10y equals minus 225. Just take stock of what I did. Completed the square, factored a 9 out. Then I'm going to complete the square here. Did you notice something that I forgot? Hopefully you noticed that I added a 9 here, but I didn't account for it over here. So I should add a 9 on this side as well. So, sort of taking stock of what I have, it'd be x minus 3 squared, if I factor that, plus 9 times y squared plus 10y. Let's complete the square while we're here. Divide this by 2 and square it, that'd be plus 25. I'll go different color. Plus 25. So over here I'm going to have to add 25. So I have minus 225 plus 9. Hold on here. This 25 here, it was actually multiplied by that 9. So I have to, on the left hand side, I actually have 9 times 25. That's new. So over here, I have to have 25 times 9. Okay, so again, let's take stock of where we're at. So I have x minus 3 squared plus 9 times y plus 5 squared is equal to whatever all this comes out to. I think it actually comes out to 9. this is 225, and this, they'd cancel out, it'd just be 9. Okay, so now I have an equation where the center of the ellipse is at 3, oh, just a sec. I have to divide by 9 first. That was close. The center's not going to change, but I have to get a 1 over here, so I have to divide everything by 9. So divide this whole thing by 9, and divide this whole thing by 9. When I divide this by 9, the 9's will cancel, so I'll just be left with 1 on the bottom. Divide this by 9, you get 1. So the center of my ellipse will be at 3 and minus 5. Notice how the signs sort of switch there. Also, the one that has the larger numbers under here, so it's going to be an ellipse on its end there. So let's go up and take a look, see if we match one of those. So we have 3 minus 5. 3 minus 5. Hey, that looks to be about the center, and it's line on end. That's good. This one here, the center would be like minus 1, 2. And I'll bet if you did this one out here, that's what you would get for your center of that ellipse. So 21, I'm picking D. So this one here has got to be B. Okay, hopefully that helps you out in determining which of those equations it is. Okay.